Hello, let's do some questions on these two rules, product rule, quotient rule, and chain rule on derivatives. The first question that we are going to do now is y equal to sine square. Okay, finding the derivative of this would be dy dx. The square function first, this should be taken as sine x the whole square. Therefore, the square function should be used first, and this is a chain rule question. 2 sine x for the square, and the derivative of sine x would be times cos x. Okay, the speciality of this question is that the answer is 2 sine x cos x, which is nothing but sine 2x. So, and this is why I took this question. Derivative of sine square x is actually sine 2x. In this case, you can easily find out the difference between the square and multiple of 2 with the x. Okay, so this is a very special question which you can apply in a very special ways. The next one is x cube over 1 plus x square. You cannot do this in any other way other than the quotient rule, because if it was 1 plus x square over x cube, you could have taken 1 over x cube separately and then x square over x cube, and then you could have used the power rule to find the derivative of each term. That was simple. But the case here is x cube over 1 plus x square, and you cannot divide x cube by 1 plus x square and separate it into polynomial. So the best option is using quotient rule. Quotient rule says y dash is v u dash minus u v dash over v square. So v is 1 plus x square and u dash is 3x square minus u is x cube and v dash is 2x divided by 1 plus x square the whole square. It's always better not to simplify the numerator. Do not expand the numerator here, sorry, the denominator here, but simplify the numerator first. 1 plus x square times 3x square is 3x square plus 3x to the power of 4 minus x cube times 2x is 2x to the power of 4 divided by 1 plus x square the whole square. Okay, so this becomes, you can see that you can actually simplify the numerator, which becomes 3x square plus 3x power 4 minus 2x power 4 is plus x power 4 over 1 plus x square the whole square. And again this can be simplified, x square can be taken common, so this would be 3 plus x square over 1 plus x square the whole square. You can leave this in this format. Okay, some places you could have cancelled the numerator and the denominator if you do not simplify the denominator. That's why I asked you not to simplify it. Sometimes you might get the same term in the numerator which can get cancelled. Okay, so it's always better not to simplify the denominator until the end. Okay, if it is needed, you can simplify it while you are in the last stage of the question. So this is where you stop this question. You can just leave the answer as x square times 3 plus x square over 1 plus x square the whole square. There is no way of simplifying it further. Next couple of questions. A minus x over a plus x, and this is definitely going to be quotient rule. So quotient rule starts with the new denominator times the derivative of the numerator, which is minus 1 here, minus the numerator times the derivative of the denominator, which is 1, divided by the denominator square. Okay, this is minus a minus x. I'm expanding the numerator, in fact simplifying it, and again you would see that I'm not simplifying the denominator, so you take off this thing. So minus 2a over a plus x the whole square. So there is no use in expanding the denominator here. Again, this would be the simplest form. Okay, now coming to this question, y equal to a cos root of cos 2x. So this is obviously a chain rule question. you have a is a constant, so you don't have to worry about this. You have a square root function, and you have a cos function, and you have a 2x function. Okay, there are actually three functions involved. This is obviously a chain rule. So a stays as it is because it's multiplication. The square root function is the outermost one, so this is 1 over 2 square root of the thing that is inside the square root. You don't change that. The next function is cos, which becomes minus sine, so I put the minus here, sine, and leave the rest of the function as it is. The third function is 2x, therefore it is multiplied by 2. So this 2 and this 2 gets cancelled. So in the numerator you have minus a sine 2x divided by root of cos 2x. Okay, so this is the simplest form that you can give for this question. Sine of cos x, there are two questions here. Sine of cos x here, and here it is sin x cos x. So you should be very careful, and you should not use product rule in this question, but you should use the product rule for this question. Do not confuse between the product rule and the chain rule in these type of questions. So this is a chain rule question, the first one, while the second one is a product rule question. Okay, because this is cos x inside the sin x, and the second one is product of sin x and cos x. So the derivative here would be sine is the outermost one, therefore this becomes cos of, you don't change the thing inside, you are changing only the sine to cos, times the derivative of the cos x here, which would be minus sin x. Therefore the answer is minus of cos x times sin x. Okay, whereas here it is product rule, uv dash plus vu dash would be our derivative. So sin x and minus sin x, so this would be minus of sin x plus cos x times the derivative of sin x is cos x. Therefore this is cos x cos square x minus sin square x. Again, this is a very important result that we know is equal to cos 2x. So we have found two derivatives which led to sin 2x and cos 2x. For sin 2x, if you remember it right, the derivative of sin square x was sin 2x, and the derivative of sin x cos x was equal to cos 2x. Okay, how does it help in finding the antiderivative? So we said that sin square x on derivation gives sin 2x, therefore on integration it should give sin square x. Okay, so how does it go about it? Sin 2x, if you have learned how to integrate integral sin ax plus b, the integral of this would be similar to chain rule but not exactly. So you have to integrate the sine, which is minus cos, and then you have to differentiate the linear equation inside, and then you have to divide by the derivative of that, or since it's linear, the derivative would be the coefficient of x. So integral sine ax plus b would be minus cos ax plus b divided by a. This is the difference between the chain rule and integral of a function which is like a chain rule, which has a composite function of a linear function inside another function. Okay, this has to be linear. When it is linear, you integrate the main function, sine becomes cos, minus cos, and then differentiate the linear function and divide by that answer. Okay, so another example, say for example you have cos of ax plus b dx would be cos on derivative differentiation, on integration would be sine of ax plus b. Cos on integration is sine ax plus b, and derivative of ax plus b is a, that has to be divided, plus c. Okay, so this is how you integrate such functions where you have linear function inside another function. Okay, so in that way, if you want to find sine of 2x, integral sine of 2x, then this is cos minus cos of 2x divided by 2 whatever plus c. Yeah, now how does this connect with this? This is sine square x, but on integration using our rule, Here it is actually minus cos 2x over 2. So now it stands to be simplified. So once you simplify, you will automatically get sine square x. So you can simplify this as minus of 1 minus 2 sine square x. Let's try this out, over 2. So which would be minus 1 over 2 plus sine square x. So which is obviously sine square x plus a constant. So we don't bother about the constant, right? So the integral of sine 2x is some constant plus sine square x, which means that integral of sine 2x is actually sine square x. Hope that makes sense. So this constant is the constant that we usually add with this. So plus c, and c plus minus half could be taken as some other constant. So we say sine square x, sorry about that, sine square x plus c minus half would be sine square x plus another constant k, where k is c minus half. Okay, so we just saw how to how to find sine square x derivative, and then we got it as sine 2x, and we also did the integration to get sine 2x to be equal to sine square x. Okay, now how does this work? We just did the derivative of sine x cos x to be equal to cos 2x. So is integral cos 2x dx equal to sine x cos x? Let's see. So using the same rule, cos of a linear function would be sine of the linear function over the constant, right, plus c. Now sine 2x could be easily written as 2 sine x cos x. So I think by now you can see the answer coming up. So this is actually sine x cos x plus c, and that's what we got. Sine x cos x on derivative became cos 2x, and cos 2x on integration is actually sine x cos x. Okay, let's continue with our chain rule and quotient and product rules. Ln of x square plus x, y equals. So what type of function is this? This is a chain rule, this is a composite type. X square plus x is a function which is being plugged into the ln function. So the outermost function is ln, so 1 over x square plus x for ln, and then derivative of this multiplied by 2x plus 1. So there is no way of simplifying this, but you just leave it here. Okay, what about this? There are 2 or 3 things that's combined. So you can see that this is a product rule, and this is a quotient rule, and I don't see, okay, this is a chain rule. Okay, there are all of them combined together. So how does it go now? Let me take off these colors so that it's easy for you to understand. Now let's concentrate on ln x over 1 minus x. Okay, then we'll find ln of 1 minus x, and then we'll add them up. Okay, so we'll do them separately. X ln of x over 1 minus x. So if I call this as u and this as v, then by rule, which is quotient rule, v derivative of u minus u derivative of v divided by v square. Okay, which would be v is 1 minus x, and derivative of u is now something difficult. So we have u is equal to x ln x. Now it's a product rule, so u dash is x 1 over x, which is the derivative of ln x, plus ln x times the derivative of x, which is 1. So this cancels, and this is 1 plus ln x. Clear? So the derivative of u, which is x ln x, is 1 plus ln x, minus u is x ln x, therefore substitute as it is for u, and v dash, it's easy, 1 minus x derivative is minus 1, therefore this becomes plus, divided by 1 minus x the whole square. I don't expand the denominator. Can we simplify this? 1 plus ln x minus x ln x. This is the simplification. This is the simplification of these two brackets. until now, and then we are left out with this part x ln x divided by 1 minus x the whole square. Okay, so you can simplify this. You can see that this gets cancelled, therefore this is 1 minus x plus ln x over 1 minus x square, and that's where you stop. You can't simplify this further. Okay, let's continue with one more question here. Looks nice. ln of x, okay, sorry, we didn't actually finish the question here, right? This is this part of it that we have achieved to get the result, but here you have this to be done. Derivative of this is 1 over 1 minus x times minus 1, therefore this is minus 1 over 1 minus x, therefore minus 1 over 1 minus x would be the answer here for the second part of the function, right? The first part of the function gave you this one, and the second part is here. Therefore this would be your final answer. You can still simplify this by taking common as 1 minus x the whole square. It doesn't matter if you don't simplify, but it's possible to simplify here. 1 minus x times the numerator. So as I see, I don't see any use of simplification here, minus 1. So you can actually leave it here. The only thing that would cancel is this 1 times 1 with the minus 1 here. So that's the only possible cancellation here. So I don't think you should bother about simplifying this type of questions. Okay, now let's come to a question of this type. This is ln function, and x plus square root of x square plus a square is plugged into the ln function, therefore it's a chain rule. And again there is another chain rule for this. Square root of a square plus x square plus a square is supposed to be done as a chain rule, which would be 1 over 2 root times derivative of x square plus a square would be 2x. So this cancels, so it would be x over root of x square plus a square, and we'll use this somewhere here when we are doing this. Derivative of this would be, first is ln, therefore this is 1 over the function inside. Don't change this anyway. Next is the derivative of this whole bracket. So for that, the first number is x, first letter is x, so x on derivative becomes 1, and then we just found out that derivative of x square plus a square is this much. So x over root of x square plus a square. This can be simplified, definitely. 1 over x plus square root of x square plus a square is kept as it is, and here this is 1 and this is x over this, so I am taking root of x square plus a square common, and then this would be root of x square plus a square and plus x. So you can see that something gets cancelled. This and this are the same, therefore I can cancel these two things, and my final answer would be 1 over square root of x square plus a square. This is a very beautiful result, because the question that we started was looking really complicated, which was ln of x plus root of x square plus a square, and this simplified on derivative differentiation to x square, just x square plus a square. So if you integrate this, you will get this. Now this is a question here, y equal to x ln x minus x. This is the equation given, and you are supposed to find dy dx. Hence you are supposed to evaluate the integral ln x plus 1 over x. Okay, so function is y equal to x ln x minus x, and derivative would be, here it's product rule. So first function times the derivative of the second function plus second function times the derivative of the first function. Okay, this is just for x ln x, and minus x becomes minus 1. So this is 1, this is ln x, and this is minus 1. Therefore the answer is ln x. So what we had is differential of x ln x minus x with respect to x was equal to ln x, right? Therefore the integral of ln x with respect to x would be equal to x ln x minus x plus a constant c. So that's okay. But the question was to find x ln x, integral of ln x plus 1 over x. So we need to find integral of ln x plus 1 over x dx. But the answer for the previous question was just ln x. Doesn't mean that you need to be asked only for integral of the answer. It could be something extra here. What's happening here? It is ln x dx plus integral 1 over x dx. You can split the integration. One part of the integration needs your previous answer. The second part is a direct question. So from the previous answer, which is here, you can say that integral ln x dx is x ln x minus x, and then for 1 over x we know already that it's ln x plus c. Okay. In all ln x cases, it's advisable to use a modulus of ln x because this value x cannot be less than 0. It's always positive. So it has to be an absolute value of x so that you are sure that you are showing a positive value inside the ln function. Hope that's clear there. Next, find the equation of the tangent to the curve y equal to x square sine x. So finding the equation of the tangent has some process there. You are given the y function y equal to f of x, and then you find f dash of x, and then you are given the point x is equal to say a, and the derivative of at that point would be your slope, and then use that value in the equation and use x is equal to a and corresponding f of a. Substitute the value of a here and find f of a, which is y. So you have x, you have y now. Substitute the x and y value and find c. Once you are done, go back and substitute it in the equation y equal to mx plus c. So that's the process of finding the tangent using derivative. Let's do the same thing here. So the question is at x is equal to pi over 2. So you are given x is equal to a. Now find the corresponding y value. When you substitute pi over 2 here, this is pi square over 4 sine pi over 2, which is sine pi over 2. We know that it's 1. Therefore, this is pi square over 4. Therefore, the points that we are going to consider are these x and y points. Okay, that's what I'm going to substitute when I'm going to find the c. But before that, I need m. So m is actually dy dx at the x value given. Okay, for that I need dy dx, which is product rule, x square first function times the derivative of the second function plus second function times the derivative of the first function. Now don't go for simplifying this because you are just going to substitute x is equal to pi over 2 here. So just substitute it directly. Pi square over 4 cos pi over 2 plus sine pi over 2 times 2 times pi over 2. Now cos pi over 2 is 0, and here it is cancels here, and sine pi over 2 is 1, therefore this is pi. Therefore m, which is dy dx at pi over 2, is pi. So the equation is y equal to pi x plus c. Now to find c, I'm going to use this coordinates, which means pi square over 4 equals pi times pi over 2 plus c, which means c is pi square over 4 minus pi square over 2, which becomes minus pi square over 4. So substituting this c value, you will get y equals pi x here and minus pi square over 4, and that would be our final answer for the equation of the tangent. Now let's do some more problems which was a bit more complicated than this, and which gives a beautiful result by the end of it. 1 plus sine x over 1 minus sine x. Again, this is a chain rule. and a quotient rule. In chain rule you have ln function, you have square root function, you have a quotient function, right? All of them. So this is why. Before going further, you know that there is a quotient rule involved in that. If you are not comfortable doing one after the other simultaneously, you just take out this. So when you want this, you can plug them into your chain rule methods, right? So anyway, somewhere you will be needed to simplify this. You will be needed to differentiate this. So this is quotient rule. Start with the denominator, and then the numerator's derivative is this minus the numerator and the derivative of the denominator divided by the numerator square. Again I insist, do not simplify the denominator square, and do not simplify the denominator. So this becomes expanding cos x minus sin x cos x minus or plus cos x plus sin x cos x on the numerator, and the denominator stays as it is. Okay, so the things that cancel is these two. So 2 cos x divided by 1 minus sin x the whole square. So this is what we'll be using later. Now coming to this side of the question, ln is 1 over root of 1 plus sin x over 1 minus sin x. The root is for everything. Okay, times for square root 1 over 2 root of whatever is inside, just put them in. 1 minus sin x, and then you are going to find the derivative of this quotient, which we have already found, which is 2 cos x over 1 minus sin x the whole square. Again, now this is a matter of simplification. So the calculus ends here. The next step is normal algebra. So if you simplify these two, which would be, the roots would go, they have the same functions inside the root, therefore the roots would go. It is 1 plus sin x over 1 minus sin x times 2 cos x over 1 minus sin x the whole square. So as you can see that if you had expanded the denominator here, you would have found it very difficult to cancel. But now you can cancel 1 minus sin x with one of them here. So this and the 2 cancels. So this would be cos x over 1 plus sin x, which is here, times there is one more 1 minus sin x in this place. So which would become cos x over a plus b, a minus b is 1 minus sin square x, which is cos x over cos square x, which is 1 over cos x and secant x. So it's the function becomes so simple when the actual function was a really complicated one. So what did we find? Derivative of ln of root of 1 plus sin x over 1 minus sin x is equal to secant x. Therefore integral of secant x would be ln of this plus c. That's very simple when you are going backwards on integration. It is advisable that you do this again in a sheet of paper yourself to understand what is actually happening. The next function would be to find the derivative of e power 2x minus e power minus 2x over e power 2x plus e to the power of minus 2x. Again, this is a very beautiful question. Okay, the maximum chain rule that you are going to use here is e power 2x would be 2e power 2x, right? That's what we are using here. So if this is y, the derivative would be denominator, this is quotient rule, denominator times the derivative of the numerator, which is 2e power 2x. E power minus 2x would be minus 2e power minus 2x. Okay, so in this case e to the power of minus 2x would be plus 2e to the power of minus 2x. Let me take this off. Minus the numerator times the derivative of the denominator, which is 2e to the power of 2x minus 2e to the power of minus 2x, and the denominator would be divided by the denominator square. That I'll write it later. Just keep it as divided by the denominator square. Let's simplify the numerator. E power 2x, 2e power 2x becomes 2e to the power of 4x. E power 2x, 2e power minus 2x becomes 2, because e power 2x times e power minus 2x is e power 0, which is 1. So it becomes 2. And next term is e power minus 2x times this would be again 2, because minus 2x and plus 2x in the power. And the next one, e power minus 2x, 2e power minus 2x would be 2e power minus 4x, and the same thing here, but be careful with the negative sign outside. So minus 2e to the power of 4x, the first terms, and then would be plus 2, which is this and this. Next, this and this would be plus 2 again, because there is a minus and the minus. And then this and this would be minus 2e to the power of minus 4x divided by the denominator square. Now anything cancels here? Definitely. 2e power 4x cancels with minus 2e power 4x, and 2e power minus 4x cancels with minus 2e power 4x. So you have 2 plus 2 plus 2 plus 2, which is 8, over the denominator square, which is the whole square. And this is the answer for this question. Hope this was helpful. Have a nice day. Bye bye.